Okay, good morning again. So we are here at part 2 of our law of signs presentation, and we're going to talk about the ambiguous case, which I alluded to in the first video. So the ambiguous case, as you might imagine, involves the word ambiguous, and ambiguous means unknown, unclear. So here's our situation. Let's say that we have a potential triangle here, where we know the length of side B, which is right here, and we know angle A, which is right here, and we have some third side, which is going to be side C, which is of any length, infinite length. And then we have side A, and side A will be across from angle A. And as we learned earlier in the first video, side B, of course, will be across from angle B, wherever that happens to be, and side C will be across from angle C, which will be up there. So again, we have a known angle and a known side, and we now have a known other side, and we're going to call that side A. And A, again, is going to be across from this angle right here. So A is going to start up here and head down in this direction, and we're going to see where it meets the infinite length side here. So let's do case 1, where A is a very short side, sort of like, Tyrannosaurus Rex arms can't reach anything. So here's where we're going to be right here. Oh, that's not even clear enough. All right, we'll do it this way. We'll fold it twice. Okay, so let's say that our side length is this much right here. So if we try to form a triangle with this side of this length, it's a little hard to work with here, we can see that there is no triangle we can make here. This side length here just isn't long enough to reach the third side, so we get no triangles at all. 0 triangles. Okay, let's say that we have a different side length for A, not that really short Tyrannosaurus Rex side length, but let's say it is this side length right here that is exactly that length right there, which is perpendicular from the top of side B straight down to the infinite side there. We can see that we will only form one triangle, and that's the triangle that happens right there. If we swing out in that direction, no triangle, right? The side isn't long enough to reach the other side. So when we get down to here, where we're perpendicular, it just reaches the infinite length side once. So if side A is the same as the altitude of the triangle, we will have exactly one triangle, and it will be this right triangle that I am indicating right here by the 3 sides of this diagram. So that's case 2, where side A is not Tyrannosaurus Rex, but kind of the Goldilocks, just the right length where we get exactly one triangle. So let me make the side just a little bit longer than the altitude, and let's make it this length right here. And so we can see that if we're perpendicular, we actually don't form a triangle. We've gone too far, right? Where my thumb is, we've gone too far. But if we swing back this way a little bit, we get this really weird little triangle over here on the side, which is kind of an obtuse triangle. Or we swing out in this direction, and we get we get another triangle over here. So we end up with 2 triangles, one there and one there. So there are 2 triangles that we can form. 2 triangles. So far we have Tyrannosaurus Rex side, no triangles. We have Goldilocks side, just right. We get exactly one triangle when it's equal to the altitude. And then we have the case where if the side length is longer than the altitude, by a little bit anyway, we get 2 sides. Now let's make this side really long over here. And we swing back in this direction, and we see that we're going to hit our infinite length side way over here, which we are no longer at an acute angle. So if we swing over in this direction, we see that we're going to get one triangle over there. So again, we're back to the one triangle show. So what we see here as we are doing this demonstration is we have cases. Tyrannosaurus Rex, not long enough, no triangles. Goldilocks, exactly long enough, one triangle. A little bit longer than the altitude, a little bit longer than Goldilocks, two triangles. Really too long, only one triangle, not a triangle in this direction. So there's your demonstration of the ambiguous case in which we have either 0 triangles, 1 triangle, or 2 triangles. Back to part 3.